we will be talking about how to build an API. And tonight we're going to talk about Node.js and Express, and we'll go through those topics. You can see the objectives here. We want to explain what Node is, explain what Express is, and then be able to create an API using these tools. And then, I think that the training kit talked about another utility besides Postman that you can use. I think it's called Insomnia. I'm not familiar with it. We'll be using Postman during this class. And then on Thursday, we'll talk about a feature of Express called middleware. And then we'll talk about deploying to the web and best practices there. And then in future courses or lectures, we'll talk about adding data persistence, authentication, and testing. And then you guys all have a chance to dig into your project after that. So that's a little bit about me and about the class. And let's take a quick peek at our guided project, which is where we're going to focus mainly tonight. So if we look at the project, by the way, in terms of how class will run and what I'd like to see happen, I'd prefer it if you could fork and clone the project before class starts, expecting and assuming that you've spent time in the training kit and the preparation videos and so forth there. And then we'll just focus on the guided project and going through that. You'll get a chance to, we'll talk about the different pieces of the project, and you'll get a chance to see it and ask questions. And of course, there'll be plenty of time for you to do your own coding. So while I'm coding and you get a chance to see that happening, I'll also be explaining and describing what's happening. And so it will be best for you to pay attention and focus during those times. Try to avoid the temptation to jump into your editor and follow along that way, because you may miss something that will be really helpful. So I'll make sure you've got plenty of time to catch up and get your own code into good shape there. So if we take a look at the project, sorry, there's a question, two questions I'll answer. Any relation to Brian Kirkby? Yes, he's my brother. I probably should avoid the temptation to call him my little brother. Maybe my younger brother, we'll call him that. But yeah, Brian is my brother. In fact, he's the one that got me interested in Lambda School to begin with, and so we could owe it to him that I'm even here. We'll see if that's a good thing or not. I think it will be. Using Code Sandbox, no, we won't. So this is something that will be different from, thank you, it's great to be here. Brian's your favorite instructor. I'm glad to hear that. He's probably one of my favorite instructors as well. He is my younger brother, but in a lot of ways I do look up to him. So I got him into the industry. He took it where he is now, so I'll give him all the credit for that, but he's an awesome dude. But in terms of using Code Sandbox, I think in the front end stuff that you've been doing to this point, you've had the ability to use some hosted environments like Code Sandbox and maybe others. Working on the back end is a little different, and I think you'll get a chance to see why it's different as we kind of dig into that. We won't be using Code Sandbox, we'll be using Node. There is an opportunity to use hosted versions of Node, but in our case, we're going to have it installed locally. And so that's something that you should have been able to do through going through the training kit, is to get Node installed, as well as NPM or Yarn. I'm actually prefer Yarn, so I'll be using Yarn in our projects here. But everything that we'll be doing will just be on your local machine, at least initially. So no Code Sandbox. Okay. So about the guided project, again, if you look, once you've got it forked and cloned, you'll see it's just a typical node project. We have a package.json file, which we'll talk a little bit about. There's some other support files here. We can talk about connects. It's one of the things we're going to dig into when we get into data persistence. There's a data directory that has some things in it, including our database that we'll be using a little bit today. You'll get a chance to peek at that a little bit. And then this hubs model, we'll talk a little bit about what that file is a little bit later tonight as well. What is missing here is an index.js file, and that's where we're going to start. We'll begin from scratch and creating an index.js file, which is what we'll begin executing. And again, hopefully you have Postman installed locally, whether you're using a Mac or Windows, you can have that installed, and that'll be important. We'll talk about the role that Postman will play as we get into that. The database that we are going to be using is SQLite. And then there's a layer on top of that we'll be using called connects. We'll talk again more about that in depth later, so don't worry too much about that, but just be aware that some of these files are related to SQLite and connects. One other thing I will mention is that if you look typically in a node application, you've got a package.json file, which is where the dependencies for the project are identified. So other packages that your project needs in order to run it successfully will be listed there. And then there's some other things we're going to take a look at scripts that are defined in package.json and how that works. NPM has a feature that will create a lock file for package.json. It's actually called package-lock.json. And that allows you to prevent some challenges that can come with dependency management later. The challenge that we have is that Yarn has the same capability, and there's a weird, ugly kind of warning that Yarn will pop up if there's a package-lock.json file. And in order to prevent that, I just renamed mine. Yarn will create its own lock file that performs the same function. And you don't have to rename this one. It just, I got tired of looking at the warning, so something you may want to do. So again, as far as the project goes, these are the files that are there. So let's take a quick peek at package.json. You can see here there are dependencies that are defined for our development environment. We're going to talk about NodeMon here in a minute, and other dependencies including Express, SQLite, and connects. And then up here in the scripts area, you can see a script that's defined called server, and then a command that gets executed. And the way that you run that, you can do it with NPM or with Yarn. With NPM, you would use the npm run command, and by typing npm run server, it will execute this command here. For Yarn, you can just type Yarn server. It doesn't have a run command, doesn't need one, but it does the same thing. It'll execute this. And you can see that the command that it will execute is nodemon index.js. And essentially, what this is nodemon is an application that will monitor your index.js file, and it will run node and load your index.js file and begin executing it, but it'll monitor index.js. And so every time you make a change and save index.js, it will, nodemon will restart the application. So you don't have to do that manually. If you were just executing it by using node, then you could make a change to index and save it, but you'd be required to stop your server and restart it. Otherwise, it wouldn't need a yeah, so you'd have to, otherwise it wouldn't have access to the new features that you've added. Yeah, Robert says it's like less monitoring, which is accurate. Okay, so let's talk just a little bit. We're going to review some of the material in the training kit. Let's talk about backend first, the concept of backend. And let me give you guys a chance to kind of weigh in based on your studying. What do you think backend means? What is that concept to you? Let me get some comments from you guys, and then maybe I'll add some of my own. Server side. Okay, I like the server side. Handling how the server interacts with the front end, that's also accurate. Serving data to the front end, serving up information, data handling, data management. Okay, it looks like you've got a pretty good handle on the concept. There's a number of different infrastructure for interacting with databases. There's a number of different metaphors that people have used to kind of describe what backend means. They all boil down to these things that you guys have said, so you've got a pretty good handle on it. I will just add my own viewpoint, and along the way, you'll hear something that'll really kind of click. What I have found that works for me in terms of being successful in developing software, in particular on the back end, is viewing these applications principally around their need to communicate with one another. And so every application, all the front end stuff that you've been doing to this point has an interface. When you create an application that a user uses, you develop an interface, and that interface has different components to it. Buttons, text boxes, drop downs, layouts, colors, fonts, and so forth. That defines the interface, and who consumes that interface is the end user. On the back end, there is also an interface, but back-end applications or back-end systems are not consumed by end users, but rather they're consumed by other applications. Okay, so we'll talk a little bit about what the interface looks like for a back-end system. It can include databases, but it doesn't always have to. It's basically any kind of service, whether it's data, computation, or action and activity or eventing that needs to occur in support of something that another application needs. Whatever is performing that function can be considered backend. Typically, you think of front end and back end in terms of stuff users see, and then stuff that what users see needs to interact with. But you'll find in your careers that there are many times there are systems and applications where back-end systems are providing services to other applications that are not user-facing. And at the same time, it's possible to have something that is presenting an interface to the user, but that is also considered a back-end service. So they don't necessarily have to be separate, but it's really important, at least to me, in my mind, to keep those functionalities separate and individual. Okay, so let's switch over to talking about APIs. How would you define an API? What do you think an API is? Okay, application programming interface is what the acronym stands for. That's correct. Okay, instruction manual for data management. I'm not quite sure where that would fit in, but there might be a place for that to fit. Interaction handler, consumable data, point where an application talks to another. Okay, that's a critical component of it. Communication between applications. And that, to me, that kind of sums up really what the whole purpose of an API is. A place where data is stored to be received. I would say no, that would be considered a database or a data store, but an API would be used to provide access to that data. Okay, so think about it this way. Again, thinking about front-end applications as applications that users use, and those front-end applications have an interface like buttons, drop-down menus, text boxes, and so forth. Back-end systems also have an interface, but the interface that they have is not visual. That interface is basically controls or components that other applications use to manipulate it. That manipulation could be to retrieve data, but it doesn't always have to be. It could be to ask it to do something and then report back on the status of whatever it did. Those interfaces are what we would call application programming interfaces. If you look back through the history of software development, APIs have taken a lot of different forms over the years. Today, because we live in a hyper-connected world, APIs principally, it's almost impossible to think about them without thinking about network communications, especially over the internet. But APIs don't always have to involve internet communications. So an example of that you could consider, for example, is to consider Axios. If you have experience working with that, that's a wrapper around different functionalities that you interact with through methods and functions. Those methods and functions comprise the API for that system. When we think about back-end systems, they may have access to data, they may perform functions and so forth. We want to create an interface that allows other applications to access that data or cause it to perform that function or retrieve some status and so forth. And so sometimes those APIs or those methods are synchronous, sometimes they're asynchronous, meaning sometimes you make the call and you have to wait for the response. Sometimes you can make the call and then continue on with your work and wait for the response later. In some cases, you'll find APIs that you make the request and the API will never report back. You have to constantly go and ask it, what's the status, what's the status, what's the status? Those are probably some of my least favorite APIs, but they are APIs nonetheless. We're going to try to not write APIs that are lame. So our job is to try to teach you how to make APIs that are not lame. One of the most common types of APIs that we have today is something called a REST API, R-E-S-T. So Jimmy, you just mentioned RESTful. REST APIs are really important today, and we'll talk a little bit about why. REST stands for Representational State Transfer. And essentially they're APIs that are meant to leverage the infrastructure of the internet. So if you think about the internet, in fact, most people call the internet the web. Turns out that the web and the internet are not the same thing. The web is a subset of the internet. But for many people, they are one and the same. And that's because their interface with the web began with a browser and talking to web servers. There's a particular protocol that browsers use to communicate with web servers. It's called HTTP, Hypertext Transfer Protocol. And that protocol has certain functionalities or certain capabilities within it that allow people who design the infrastructure on the internet to create caches and routers that are optimized for HTTP. And that's because of the sheer volume of people that are using HTTP as a protocol. Anytime somebody pops open a browser on their phone or pops open a browser on their desktop, they're using HTTP. And because of the sheer volume of that, the infrastructure designers on the internet can make routing and sorting and serving of responses to those HTTP requests much more efficient. That puts us in a really good position because we can leverage that infrastructure by designing APIs that use HTTP. And when we do that, we gain all the benefit of that infrastructure. If you know anything about HTTP, then you know that any request that an HTTP client can make of an HTTP server will have what's known as a verb in that request. The verb basically indicates to the server what kind of action you want that server to perform. The get verb, as an example, will tell the server, get something and return it to me. There's a put verb that tells the server, I'm giving you information, I want you to save it. Likewise, there's post, which can do the same thing, but they have some differences in how they work. There's a delete verb that tells the server, I want you to take something that you're currently storing and I want you to remove it. And of course, the server has to be willing to do these things, and you provide other information along with the HTTP request that tells the server what to do. So typically, again, this happens in a web server, web browser kind of interaction. What we're going to do when we create our own API is we are going to create an HTTP server that is not a web server. And we're going to use HTTP client that is not a browser. We will use a browser some tonight, but not exclusively. Okay, and so very often, as many of you identified, when it comes to APIs, they very often have to do with data. And with data, there are 4 basic functions that you can perform. With data, you can create things that you want to have stored in your database. You can read things from the database. You can change what's in the database or update it. And then, of course, you can delete it or destroy it from the database to remove records or other information from the database. Those four functions are represented in an acronym called CRUD. C for create, R for read, U for update, and D for delete. And so as it turns out, each of those functions has a very easy correlation with an HTTP verb. Creating can be done with posting. So the post verb in HTTP can be used to create stuff. The get verb in HTTP can be used to read things. The put verb can be used to update things, and the delete verb can be used to delete things. Now, there are other things that you can do in your API with the many other HTTP verbs that exist, but these are the 4 that we're going to focus on tonight. And so there's a really good correlation between what we want to do with our data and the API that we're going to create tonight principally has to do with dealing with data, with CRUD interactions with data. And you'll see that works out really well with respect to HTTP. Okay, so let's turn to talking about Node. Tell me what you know about Node in your studies. What is Node? Okay, it's JavaScript base. It's a runtime environment, which is correct. JavaScript outside the browser, also correct. Okay, running JavaScript in the terminal. It could be in a terminal, also be in the background. Non-blocking I/O, which is a feature of JavaScript itself, but of course, because Node is a JavaScript engine, it will have that same concurrency model. Runtime for desktops and servers, okay. Good. These are all accurate, very, very correct. When it comes to JavaScript, if you consider a browser, for example, and its ability, and by the way, yes, Node is open source, which is really cool. And it uses other things that are open source, and we'll talk about that. But when you think about a browser's ability to execute JavaScript, let's take Chrome, for example. Chrome is an application that was created by Google, and its ability to execute JavaScript is performed or handled through a service or a system called a JavaScript engine. It turns out that the team that created Chrome is not the same team that created the JavaScript engine. They're both from Google. They're both Google teams in this case. But the team that created the JavaScript engine made it available to the people that created the browser, and they did it for the browser in particular. But they did it in such a way that JavaScript engine can be embedded and used in other types of applications. And so the Node creators took that JavaScript engine and created a server out of it so that we could execute JavaScript on the back end without having to do it on the desktop or in a browser. Why would we want to do that? Why do you think that's an important thing to be able to do? I mean, there's so many other languages we could write back-end systems in, but why would we want to do it in JavaScript? Okay, simple, consistency, one language, large talent pool, which is really true. You got an incredibly quickly growing group of people that know JavaScript. Okay, continuity. Okay, you don't have to change your brain ideas from one language to another, so context switching is not an issue. It's powerful. Some might argue with that idea. I think that it's growing in its power. It depends on what you mean by power. If you're talking about the ability to get low level and manage memory and access registers and other network and low level resources, JavaScript doesn't provide that. But depending on what kind of application you're trying to create, you don't need that. And so it is powerful for what it can do, but it can't do a lot of things that it can't do. So it's just a matter of deciding if it's the right tool for the job. It is powerful. It is a great language. Wesley, you said because we already know JavaScript and there's lots of libraries, Jonathan mentioned, it's open source. That's one of the main benefits I think you can find is as a software company, if you're creating a new application, you may choose to base it on Node simply because you already have a large talent pool in the company that understands JavaScript. And they can begin without having to retrain or hire new people, to get in and do that. And it is a very rapidly growing community, and you've got lots of other variants of JavaScript as you guys have had a chance to look at, including TypeScript and other things that, CoffeeScript. There's so many others that, people improving it. You have other JavaScript engines that can be embedded, lots of different things that you can leverage by choosing to base things on JavaScript. Okay. One thing that I will say about the JavaScript engine that's in Node in particular, one of the things the optimizations I really like about it is that it compiles JavaScript to machine code before it begins executing. So it's not an interpreting engine, it's a compiled engine, compiling engine, which I think is really, really cool. And it makes your JavaScript code execute very, very, it's very performant. It executes very quickly. And that wasn't always the case with JavaScript. And so a lot of people avoided it because of performance issues, but now we don't have to necessarily deal with those. Okay, good. So hopefully you'll get more of a taste of Node. And there's another kind of environment or place where we can execute Node code, and that is in, for example, in Amazon Web Services. They have a service called, interestingly, it's called the Lambda service, not related to the school. But lambdas are ephemeral functions that it's in a realm called serverless development, but it's possible to create JavaScript or Node applications that an Amazon Lambda can load up, execute, and then it goes out of scope and dies, so that you don't have to pay for a server that's constantly running. And the ability to develop that in Node is really awesome. You don't have to do it in Node. You could also develop Lambdas in C# and in Python, which is a really popular language, and many others. But the fact that you can do it in Node is really cool. And the company I work for, we use Node quite a bit for that, as well as Python and others. But there are some instances where Node fits the bill for us. Okay, let's, by the way, the idea that you can embed the V8 JavaScript engine, which is what Amazon or Google built, into other programming languages is really cool. You can do that. I've looked into embedding it in .NET applications and in others, and it's really, really cool. So let's turn to Express. We're going to talk a little bit about Express, and then we'll actually get into doing some code. So with Express, what is Express, and why would we want to use it? And as you're answering that, by the way, there's a question. I thought V8 powers Chrome, and I'll just revisit that. Again, V8 is a JavaScript engine that's embedded in Chrome, but it's also at the heart of Node. So Node is behind, or V8 is behind Node. It's also part of Electron as well, so good. Okay, so as far as Express, it's a framework for routing requests. Okay, that's accurate, but maybe incomplete, and maybe we'll be able to round that out and fill it in today. So you're headed in the right direction there. An HTTP middleware, it's kind of interesting. I'm going to talk a little bit about middleware as we go, because middleware is a feature of Express, but it's also a broader term. So in some respects, I'm not super pleased that the Express team chose to use middleware as one of their features, because it really means something much bigger than what they're using it for. But it does provide middleware for managing HTTP requests, okay? It allows us to create HTTP servers using Node. That is absolutely correct. To be clear, we can create HTTP servers in Node without Express, but Express makes it easier. There's a lot of efficiencies that we'll get from using Express. Excuse me. My throat's getting a little dry. Okay. A simpler API than Node? Not exactly. Express is a package and a service that we execute, or a module that we can execute or use in Node. I apologize. Thinking as React for servers is not far off, but we'll get a chance to dig further into it and see how accurate that is. Okay. All right, so let's dive into some code. I do want to, before we do that, do just want to talk about Yarn and NodeMon. Hopefully you have Yarn installed. If you're using NPM, that's fine. You'll just need to translate the commands into NPM commands, which is fine. But I'll be using Yarn. NodeMon is an application that you can install with Yarn. In fact, let's dive into doing that. I've got my terminal open in Visual Studio Code down here. And with Yarn installed, to get NodeMon installed, and I'll explain what NodeMon is here in a minute, you would do yarn add NodeMon. You'll see here that it'll warn me that I already have it added, but this is what you would do. Basically, what NodeMon will do for us, as I mentioned before, is it will monitor your index.js file and keep the server running and restart it every time. And yes, if you're using NPM, it's NPM install. So that's what NodeMon is, and we talked already about the package-lock.json file. This is one of the places you would get that big ugly warning if you don't rename the file, which doesn't hurt anything, but it's just irritating to me. Okay, so let's begin. We're going to start. Our very first thing we're going to do is create an HTTP server using Node and Express. Okay, and so what we're going to do is we're going to create an index.js file. And again, just follow along with me online here, and then you'll get a chance to catch up. I'll give you a chance to do your coding. The first thing we want to do is we want to bring Express into our environment and make it available as a module. Okay, so in our code, we're going to create a constant using the require command and then identifying the module that we want to require. Now, in order for this to work, what do we have to do? Because right now, I actually have Express installed, but assume we didn't. What would we have to do to make that work? Yarn add Express, that's exactly right. So I'm going to go ahead and do that just to make sure. I'm one of those developers that anytime I write something in my code that I know breaks my application, I go and do whatever I have to do to make it work and fix. I don't like my application to ever be in a broken state. So here I made it a statement. It's only a one-line statement that already made my application invalid, so I needed to come and add Express. That's just a personal style. Other people do it differently, but that's just the way that I do it. So we're going to create or bring that in as a require. Note that there's another form of syntax that you can use here to do require, and that's using the ES 2015 import syntax. If we were to do that, it would look like import Express from Express. However, that syntax in ES 2015 is not supported in Node. So this method is what we have to use in order to bring it in. Once we have it, now we want to create an object that we can use to interact with the Express module. I'm going to call mine server. And the object that we brought in with our require method is called Express, and it is itself a function. So we'll just call Express, and that will instantiate Express in our environment and assign it to a variable called server. Now, server has a method on it called listen. Okay, so I'm going to pause for a minute here and just give a little bit of background to the TCP protocol. If you've heard of the protocol stack that runs the internet, it's called TCP/IP. TCP stands for Transmission Control Protocol. And it is what's known as a connection-oriented protocol that runs on top of IP, or the internet protocol. And none of that's really important. You don't really have to understand that to make any of this work. But there's some elements of TCP that we are going to interact with that I think are kind of nice to understand. One of the first things we do with this listen command is we have to specify a port number. Okay, now the port number basically specifies an endpoint for your TCP stack on your local machine or wherever the server's running, so that when requests come in, when an HTTP client, by the way, HTTP is a protocol that runs on top of TCP. So HTTP actually uses TCP just at a little lower level. But when an HTTP request is sent out, a TCP port is sent as part of the request. And that port, when it's received by the server, tells the server essentially which application that request should go to. Because the server could be running many applications that are all listening for TCP requests coming in. And so the port number is just a way for us to identify, by running this, we're telling the server any requests that come in on port 4000 as an identifier belong to me. Okay, so make sure they get routed to this application. So that, and then somebody I'd seen in one of the previous videos I watched talked about, asked how many ports can you have? It's either 32K or 64K. I'd have to look it up, but it's in the tens of thousands. But many of them, the port numbers are what are known as well-known ports, and there's actually a registry that's maintained by an internet governing body that identifies what these well-known ports are. One example of a well-known port is port 80. That's the typical HTTP port that web servers listen on. And so it's just kind of agreed upon everywhere on the internet that port 80 is used by HTTP servers. HTTPS, which is a secure version of the HTTP protocol, an encrypted version, is on port 443. FTP is on port 21. It actually uses both ports 21 and 22. And there are others that are very well-known ports. So typically when you create a server, you want to choose a port that is not a well-known port. And that's just a function of you becoming familiar with what are well-known ports. 4000 is not a well-known port, at least not that I'm aware of, and certainly not being used by any other service that's running on my computer right now. If it was, when I started this application, I would get an error saying you can't use that port, something else is already using it. So in this case, we'll use 4000. And then in addition to that, we need to tell the listen function what to do after it begins running and listening on that port. So we're just going to do an arrow function here. And we'll just do a simple console log that logs that we're listening on port 4000. Okay, so this is about the simplest HTTP server using Express that we can create. So I'm going to go ahead and save it. And then over here in my terminal, I'm going to run yarn server. If you remember, in our package.json file, that's going to cause it to run nodemon and load up my index file in the node. And you can see now I got my console message saying server listening on port 4000. Okay, so now if I were to go over to my browser, we'll open a new tab here. And the default IP address that it's listening on is localhost. Okay, so localhost is the actual numbered IP address is 127.0.0.1. But we'll just call it localhost, and then port 4000. Okay, and you'll notice we get a strange error. It says error, and it says it cannot get slash. Okay, if I were to go back into my server and stop it, I'm going to press Control-C, which will stop the server from running, terminal, and then go back to the browser and execute or send this request to port 4000, I get it in a different message. This message says the site can't be reached. Okay. Error, connection refused. Essentially, what happened was the browser sent a request to my local machine saying this request, whatever's listening on port 4000, and my machine responded saying nothing's listening on port 4000. There's nothing there. The site can't be reached. Whereas if I go back and start my server again, okay, then go back in to my browser and execute it, then this other message. So something is sending this back. What do you think is sending this message back? Express, the server. Okay, this is the default Express. Okay, and we can say HTTP API. We really don't have an API yet. Other than that, we have a server that's listening, but that server is able to receive a request, but it doesn't know what to do with it, right? It has no idea what to do with it. So we do have Express required already. It's already loaded up in running, but it is Express that's responding. And Express is essentially saying, I hear you, I got your request, but I don't know what you want me to do with it. Okay, so its response is you asked for the root of the server and there's nothing for me to give you. Okay. So one suggestion was the browser standard web API request. It's not the browser, it's actually Express running in our node application, received the request and then responded basically saying, I can't get what you're asking for. I don't have code that tells me what to do there. Okay, so let me just a quick sec here. Okay, so that's our HTTP server. We're going to go ahead and take a quick 5-minute break. If you've got other questions, I'm happy to answer them during the break, but after 5 minutes, we'll come back and then we'll continue working on our API. Okay, so I'm going to continue to talk. Feel free to stay on if you've got questions or comments I could help with, but in 5 minutes, we'll continue to. Okay. Let's see. Doing Yarn server, but nothing is happening. Yeah, it's Yarn add express is what you'll want to do. Yarn space add space express, Chaz. So if you do that, that will add express, not only install the module, but it will also add it as a dependency in your code. And then when you run Yarn server, it should start up. Says I had to do node index.js, and that will load it, but just without the benefit of node mon. So if it will load it and begin running it, but node mon will not. See, I just request do a 5-minute break timer, and I apologize. I will do that. Okay. Let's see if I can get the code back up for you without blocking time. Okay. So there's code. You bet. Yeah, so again, we could, so I'll go ahead and cancel this, and then if I did node index.js, it'll load the server as well. None of the node mon stuff shows up. just my console out saying that we're listening on port 4000. The difference is if I were to change my port to, let's say, 4001 for some reason, and then sit, my server is still listening on port 4000. And so if I were to try to load it, it would fail. Whereas if I run the yarn server command, which will execute nodemon, now if I were to change it to 4001, oh, you know what? I have to not only change it here, but also change my message. Then you can see it'll automatically loads it, and we can listen there. I'm going to change it back to Janelle, what happens when you try running nodemon? Okay, so nodemon might not be installed. In that case, you'll want to do yarn add node. So did you do npm install nodemon? Let's see, I had to type in localhost. Okay. Do we specify the host anywhere? Localhost, the host name. So in the browser, that's where we'll go. Jamel, did you type npm install nodemon? And I realize it's in your JSON file, but you might just try reinstalling it that same way. Okay. Perfect. Thanks, Dave. That's accurate. Correct. Okay. Stop this timer. That's about that. All right. Let's go ahead and dive into our next section. Okay, so now we have this server, this Express server that's listening on port 4000, but when a request comes in, Express handles the request, but its default handling is to say, you know, your request is for the root, but I don't have anything to give you. There's no here where we've told Express what to do with that response. Okay, so what we need to do next is is to add what's known as a route handler. Okay, so the way that Express works with respect to this is all driven by these HTTP verbs that we've talked about. And I think someone posted a link before about where you could get access to the HTTP verbs. They're easy to find if you go either to Wikipedia or to Mozilla's site. You'll get a list of them there. The ones that we're going to be looking at are get, post, and delete for our CRUD operations. So what we want to create a handler, basically we want to tell our Express server when a request comes in with a particular HTTP verb and a particular URL, we want to give it code and tell it what to do. So that way, when the request comes in, it has something that it can act on. And the way it works is there are helper functions for each of the HTTP verbs, and the helper functions are the same names as the verbs. So in this case, we want to create, when we tried to browse to localhost :4000 before, basically the browser was sending an HTTP GET request for the root document. So we want to tell our server how to handle that GET request. So we're going to do server.get and give it the path that we want this particular bit of code to work for. Okay, and you'll see later we'll add a get or different paths. So that way we can have different logic for different paths that are sent in. And in this case, we want code that's going to execute when a GET request comes in or for hash. Okay, so what we pass next, the next parameter is a function. And the function will take two different parameters. One of the parameters contains information about its. Okay, so this is where we, as software engineers, developers, we can get access to information about the request that Express received. Whatever was by the client, we can access all of that. The next parameter we're going to include is what's known as the response. And this is the object that contains information that we want Express to send back. So we can control what gets back to the requester or the client using the response object. Okay, let me take a quick pause. There's some questions here. Can we get more of the why as well? I'm not sure what that's referring to. Christina, appreciate your jumping in there. If answering the question, then great. If not, let me know to add more context if we need. Was index.js created in the root folder or a source folder? I created it in the root of the, here, let me come back down here. In the root of my project folder. So I downloaded or cloned web API-i-guided, and then index is right at. Brandy mentions the homies. Response and request are often referred to, at least in Lambda school, as the homies because these go together. And also you'll see that they're often abbreviated as REQ and RES. I'll probably begin typing them that way just out of expediency, but I wanted to make it really clear that they are request and response objects. So I'm just typing out the full name. When you type out the names of the parameters of the function you pass in, they can be any name that you want to give them. Okay. Being told I'm breaking up quite frequently. That's a funny photo. I'll try not to break up. I'm not trying to break up. I am not at home. I'm in a hotel, so hope our internet will clear up. And please keep telling me if that's happening because I want to be able to go back and cover things that you're missing. But I'll try to be verbose so that we can get everything covered. Okay, so one question, can you explain different Express and using the HTTP? And I think I would complete that question by saying, what's the difference between using Express and using the HTTP module that's built into Node? So Node has its own HTTP module that would allow you to create an HTTP server. When you dig into using that, there are a lot of things that happen. And when we finish this get handler, I'll talk about what some of those are that you have to do manually that require a lot of additional effort. But it also gives you a lot more control. One thing that I do like about Express is that it defaults a lot of the things that with HTTP would have to manually do. Express will default a lot of those, but it also gives you control. It's what's known as an unopinionated framework, which means that I'll provide a lot of defaults to you into doing things in a particular way. You've got a lot of control and can do whatever it is that you need to do with it. So you could use HTTP. In fact, Express uses the HTTP module behind the scenes. So you get the same functionality as with HTTP, but Express just makes things a lot simpler and easier because of a lot of the defaults that come in. And we'll talk about some of those as we complete this. Question, is there any reason you would not use Express? That would probably, one of the reasons I could think of is if you just have a lot of familiarity with HTTP, if there's a different framework that you want to use. One of the reasons Express is so popular is because it fits the bill with respect to a lot of different dimensions, including functionality, ease of use. And so it's popular for a reason. I've personally couldn't say that I'm aware of any reason why you wouldn't use it. That's not to say that you're into it. But the fact is there's nothing that it does that you couldn't do with HTTP itself. And like I said, Express on top of it, the HTTP module. So that's an option if you want it. But it's a really easy go-to, and one that I would recommend, and many others would as well, simply because of how quickly you can get up and running with with simple HTTP servers, and even complex ones if you wanted to customize a lot of the functionality there. Okay. So back into the code. We're creating a get handler for the root document. We've got our request and response objects and put them in a function. And so we want to tell Express what to do when it gets a GET request for the root document. And in this case, all we're going to do is simply return some text. Okay, so we're going to send, you call the send method on the response object to tell it to send a message. Okay. Obviously, as our API becomes more sophisticated and more functional, we would add more capabilities in there. This is what we're going to do for now, just to keep it simple. Now, one of the things, if you look into the HTTP protocol, one of the things that you'll know about it is that when you get a response back from an HTTP server, there's typically, there's a number of different components that come back. There's a number of headers that are added in the response. There's a response code that indicates whether what you asked the server to do was successful or not. And of course, there's a payload or text or something. It could be a file if you're trying to download a file and so forth, that will come back with it. You'll notice here in our response that we're sending back, because S does represent an accurate and complete HTTP server, the response that will come back to our browser will include all required headers. It'll include a required response code, but you'll notice that we don't have to set these. If you were using the HTTP module in Node, you would have to do all of that stuff. But using Express, a lot of those things are going to be defaulted by just calling the send method and not doing anything else to the response. It will automatically add the right headers. It tries to determine the right content type header based on what we're sending back. If we were sending back a JSON object, it would automatically include a content type header that says it's JSON. It's going to assume, because we didn't say otherwise, that the response should be successful. So it will send back a 200 code response. And these are some of the things we get with Express that are automatically built in. Okay. So I'm going to go ahead and save this. You'll notice our node server restarts. And then if I go back to my browser, and refresh it, then I get my text. Okay. If we were to actually take a peek, we go into more tools and look at developer tools, and then look at what network I want. I'm trying to see where I get to it in here. There's some place in here where I can actually see the things that are going back and forth. I thought it was right here, but it's not letting me. Okay, we'll skip this part for now, but if you were able to see it, you'd actually see that the headers that come back and the response code itself comes back as 200. We'll be able to look at it. Oh, that's what it is. Okay, we'll look at it, and I'll see if in a break I can dig that up for you and show you. But we can also do it in Postman. We'll take a look there, but you'll see the headers and the response that comes back. Okay. Right, I'm going to give you a little bit of time to catch up. We'll put the code back up so you can take a peek at it. If you've got questions, post them, and I'll. Okay, request.send is not a function. It's that's a great message because you're calling the send method on the request object. We want to actually call the send methods on the response object. Okay. Yeah, so the response object is our way of telling Express what to send back, how to respond. Request, we'll get a peek at later. We'll have a chance to look at some of the elements of the request when it comes in. Question is, .send an express method or a node method? It is an express method on the response object, which is an express object. Okay, we'll take a look at that again, Kenichi. Jimmy, did you post that, Jimmy, because you're having an issue or just to help out? Because it looks correct to me. Okay, thank you. Yeah, that is correct what you have there. What I am going to do is I'm going to try out my poly skills. Okay, so if you'll just click either the yes or no on the poly, and that'll give me an indication as to whether we need to wait a little more. Okay, Morgan, is that a question or a comment? You need to add Express and NodeMon. By the way, for those of you that are weighing in, don't forget to go back and change it. Get done. Okay, so yes, you need to add Express and NodeMon. Mon is not a requirement for the application to run. It's just a convenience. And if you want to use Yarn server in order to execute it, it will try to run the NodeMon application. If you don't have NodeMon installed, it won't work. But you can run it just by typing node space index.js. But Express is a requirement. You need to do yarn space add space Express to make sure you've got Express installed. and identified as a dependency. Okay, and Marco's comment is accurate. Yarn add express node one. Okay, it looks like just about everybody's caught up. Is there anybody that needs me to wait longer? Okay. All right, so I'm gonna give you a little assignment. We'll give you a little bit of time to complete it. And I'll also field questions as we go on this. What I'd like for you to do in your application is create a handler for the get verb for the URL /now. Okay, so I'm going to kind of get it started if you see my code here. Okay, so we want a handler for the get verb coming in, the HTTP get, but where what's been requested is /now instead of just the root document. So if I were to go in and type localhost :4000/now, I want this handler to manage that. And what I'd like for it to do is return a string that represents the current date and time. Okay. There's a number of different ways that you could accomplish this. We'll leave it to you to kind of work through that, and then we'll take a peek at it in a little bit. So let's have you guys, if you have any questions about the assignment, let me know. Otherwise, we'll give you some time to begin working on that. If you have other questions, I'm happy to handle those as well. If it's not clear what I'm asking, what the assignment is, please let me know. Okay, so what we want, you can see here, we've created a get handler for the root document. So when I type in localhost :4000 or localhost :4000/ comes in, and Express knows to run this code because it's an HTTP GET request, and we have a GET method here. And the URL that I typed in was the root document, or just /. And so this is the code that's going to get executed because Express will route that request to this code. What I'd like for you to do is create a route handler for a GET request to /now. And so you'll add a different code here such that if you were to type in /now as your URL, this code would be executed. And what I want the code to do is, instead of returning text, I'd like you to return text that is the current date and time. Does that make sense? There's another yes, no question for you to respond to. So please click yes if you're done, no if you're not. And if you're not done, go back and change it to yes so that we get an idea of where everyone is. Okay. It looks like most are done. Let's take a minute and just go through what this might look like. So I've gone ahead and typed in, and I saw that Eric had posted this solution, very similar to mine. I did it in a couple of different, he did it all in line, which is fine. Your solution may be similar to either one of these, or both correct, right? So the answer was to basically get the date, turn it into a string, and then send it. One thing I do want to mention, this toISOstring method, and when it comes to dates, times, you probably want to be familiar with. It's an ISO standard called ISO 8601. And it's a standard for representing dates and times using text. It makes it possible to include dates and times in URLs, payloads, and in a very transferable format, and also taking into account time zones and time zone offsets. You can also represent time strings in addition to date strings that down to the microsecond, or the millisecond rather. So it's a very handy format to have and to become familiar with when you're dealing with APIs that work over the internet and have to go through these optimized routers, and, the infrastructure that's used to not dealing with binary data. Then it's also not easy to get confused with it. It's very clear exactly what point in time and in which location you're referring to with an ISO string. So you get a chance to see what that looks like here. So I'm going to save my file. My server's been restarted. If I were to go into Google Chrome and then enter /now, you'll see that I get this date string that includes the year, the month, the date, the day, and then it shows the letter T separates the date from the time. I get the hour, the second, millisecond, and then Z is a time zone offset that stands for UTC time. So currently 2:40 morning on July 24th in England, and that's what this time represents. Your solution was very similar. We still have a few folks that aren't quite done yet. If you need some help with that during a break, let me know, and be able to help you out with that. Okay. Let's move on. What we're going to do next is we are going to begin working with our database. Okay, so now that we know how to create an HTTP server and we know handlers that can handle different HTTP verbs with different URL requests, we can begin working on our CRUD option. So start with the R in CRUD, with the read, or the ability to get information. So we'll be working again with the get. And what we're going to do is work with a data model that was included with this project when you forked it. If we were to data for, you'll notice we have a file called hubs.db3. It's a SQLite database that contains some information that's been preloaded for you. And there's a file called hub-model.js. Okay, if we were to open this, you'll see that inside hubs.model, there's a couple of requires that allow this JavaScript file to work with connects, which basically connects is it's a SQL query builder that works together with SQLite. We'll talk more about the benefit of that, but just know that for now that this model file is interact with this SQLite database using connects, so you can see that here. And then you'll see some exports here in our hubs model file. And basically what it's exporting are some functions. There's a find function, a find by ID function, an add function, a remove function, and an update function. And if you pay attention to it, you'll see a correlation between these methods and CRUD, right? So add is our C for create. Two different methods for finding is our R for read, U for update, and our D for delete corresponds with a remove function. Okay. So we've got all the methods that we need, and each one of these methods, if you go through and look at them, you'll see that here we've got a DB object that represents our database. Each of these methods, like find, is ultimately going to execute a method on our DB object, which basically means it's going to work against our database. Okay, so in our application, we're actually, even though we're a backend service that provides an API, we're also using an API to interact with the SQL database, right? So in a sense, you can see that this API is not a REST API. It's just a JavaScript exports API. It's exporting these methods that we're going to call, and then it will do things on in the background for us, making it easier for us to interact with the database without having to know all the specifics and ins and outs of dealing with SQLite, or for that matter with Connects. So you'll see how simple that is, but that's essentially what we're going to be doing. And so with the R and CRUD, or the ability to read, what we want to do is create a handler that will handle the, I'm going to start it out here. One of the tables in our database is called hubs. Okay, and right now we'll just assume as a data object that's part of some system that we're creating. I'm not sure exactly what it's supposed to represent. Maybe you guys know, and if so, you can let me know. But they're called hubs. Okay, and there's some records in the hubs table. And what we want to do is create an API that some other using our API this data through our service. Okay. That allows us to monitor it and modify the results if we need to, going back and so forth. So we're gonna handle GET requests to the /hubs URL, and again, like all of these, we want to be able to have access to the request object and the response object, and then we need to do something inside here. Now, what we want to do is we want to call methods inside that hubs-model. What method inside hubs-model do we want to call when we're trying to retrieve data from the database? Okay, find, that's correct. The find method. Okay, so in order for us to use the find method in hubs-model, what do we have to do inside our index.js file? We have to do something in here in order to be able to access. Okay, we need to import it, right? Or since we don't actually do import, as Brandy says, we want to do require, because import is an old syntax or a new syntax that is not supported in Node. Okay, so what we're going to do is we're going to create our own object. We'll call it DB, and with it, we're going to require. And in this case, rather than requiring a module that's been installed, we can require a file that is in as part of our project. Okay, so in our case, all we need to do is type the path to that file, and it turns out the path is under the data folder, and the name of the file, in this case, Visual Studio Code just brings it up. It's reading that for me. Is this hubs-model file, and you can put the .js, or you don't have to. I like to be more complete and more explicit so people know exactly what it is I'm trying to do. So I go ahead and put the .js. So that require is going to bring into our application, our index.js file, the ability to call objects or methods on this DB object. So what's going to get returned is all of the data that's in this exports object. And in this case, it's an object that contains members that are pointers to the methods inside here, including the find method. Okay. So here we've got our file imported, and down here in our get handler for /hubs, we want to execute some code. So in our case, what we're going to do is we're just going to call the find method on our DB object. And I forgot to put a comma in here. By the way, I like these little hints that environments give us. You can see I've got these red things that immediately tell me I've missed something. What I've missed is a comma in my parameters list. So I put that in and then I'll fix that. Now, one thing that to note, and this is actually a function of connects that will surface through our hubs-model.js file, is that all of these methods in hubs-model return promises. And that's because all of the methods in connects return promises. Connects can actually do either callbacks or promises, but in our case, we're going to leverage the promise syntax. What that allows us to do is execute the find method, and then we can specify a then clause and a catch clause. So what should get returned if there's not an error is a list of hubs, right? So if we don't pass in any query information, we're just saying return all of the data that the find method will return. And in this case, it's just we'll go in and look. If we look at hubs model, the find method automatically uses the hubs table in the database, so we don't even have to specify that. Right? So just by calling find with no parameters, it's going to return everything that's in hubs. And then in our then clause, we can send some data back. And so we'll assume that whoever is making this GET request wants to get the hubs back, right? So we're going to do on our response object, we could do something like this, but we're going to talk a little bit about why it won't work. But this is just to give you kind of an idea of what we want to do, okay? Now, what's going to be coming back from the server, or from our hubs-model file, is a list of hubs in a JSON object format, okay? But what we need to send back over HTTP is text. So there's another method on the response object that we want to use. It's very much like send, but it performs an extra step of converting the JSON object into text. Okay, so we can do that, and then what we want to do is make it really clear and explicit, especially to the next engineer that will look at this code, that this is a success, right? So what we want to do is actually on the response object is we want to explicitly set the status. Now the default status is 200, so we don't really have to do this, but I find that it's typically really helpful to be super clear that we do want this to return a success. And the status method will return the response object itself, on which we can then just call JSON, so we can chain these together like that. So what this will do is set our status to 200 and then set the payload to a stringified version of the JSON object that was returned in our DB find. Okay, and that's if it's successful. Okay, and then as with all promises, what we want to do as well is have an error handler that catches our errors. And in this case is where we can basically do the same thing, but we're going to set our response status to 500, which is a permanent failure. Basically says, you know, we're not going to answer the request because something went wrong, and whatever it was that went wrong, we need to include in the payload. It could be anything. In this case, it's an error that's coming back from the hubs-model find method, and we don't know exactly what that error could be, but we're going to send it along with it, and we'll do that inside a JSON, a stringified JSON object. So we're going to call the JSON method, and we'll just create an object right inside of it. And in our case, in order to be helpful to the software engineer on the other side, we'll include a parameter or a member of the JSON object that says we were not successful, and then we'll include the error text itself. Okay. So again, going through this method, it's a get handler on /hubs. We're going to call db.find. And then upon success, we're going to set our status to 200 and return a JSON stringified version of the JSON object that was returned by db.find. And then on an error, we're going to set our status to 500 and then return a JSON object that includes a parameter that says we were not successful and then what the error was. Okay, a couple of questions here. Do you need a key for error? If you're talking about here, no, you don't. It's just an object that we'll just pass. Where does the JSON method live? The JSON method is a method on the response object from Express. So the Express response object, and by the way, one thing that I will recommend highly to you, when you're using a new system like this, is to find the documentation for the system that you're working in. In our case, it's Express 4.0. And then you can look up these things. So if we were to come in here and look at the documentation for the response object, you'll see that there's a method on the response object called JSON. And here it'll explain to you how to use that and what it does. Okay, so somebody earlier had mentioned JSON.stringify. It turns out that the JSON messages JSON.stringify. It just makes it a little easier to do that. Okay, so let's go back to our code. Oops, wrong thing. Okay, so again, we're calling db.find, setting the and returning the result, and then find and if we have an error. So I'm going to save this, and that restarts my server. And if I go back to Chrome, and call hubs, you'll see that I get some data, and it's a big JSON data that's in my database. You'll also notice that this is a little bit rough to read. It's basically an array of JSON objects. This is an extension that I think it was recommended that you install that will make it a little easier to read these things, and it's called View. So I'm going to turn that, and then I'll come back here and refresh it, and you'll notice it takes all of that data and something that's really for me to read. Okay, so it's kind of handy. And so you can see what we got back were these objects that have an ID, a name, and then a time for when it was created, and the last date and time for when it was updated. The extension is called JSON View. I think there's a link to it in the training kit. It might be at the top, if I remember. Another question, if adding one property to a certain response, is it a good practice to have that property defined in all responses for a given route handler? So the practice that you want to follow is inside the code that handles request, you make a determination for that combination of an HTTP verb and the URL are you able to fulfill that request? And if so, then you set the status to 200 to indicate. So it's on a case basis. I don't know if that, hopefully that answers the question. Okay. Let me know if that still gap there. Okay, so what I want to do now is let's give you guys some time to catch up, and then we'll take a break. We're a little bit behind where I'd like to be right now, but we'll give you a few catch up, and then we'll get a break. So let me give you guys some time, and then I'm going to put a yes, no on here and let me know how you're doing. So Jimmy, you have objects look prettier. It's because of that extension that I have installed. Christina, it's called the JSON view, and I think yeah, there's a link to the extension was posted above. Dave posted the link to it. Okay, it looks like everyone's done. So why don't we go ahead and start 5-minute break. I'll get the timer up and then we'll reconvene and move on. Okay, let's start back up here. All right, so the next thing we want to do in our to CRUD is the C. Let's add an endpoint that allows us to add new items to our database. Okay, and again, we're not so much about how they actually end up in it. Something we'll cover when we get to the data persistence module later on. But we know that it'll happen through our data hub model.js file. We'll call a method on that model to add data to the data. So what we want to do is tell our server to handle some HTTP verb on some URL. So what combination do you think we want to use here in order to facilitate creating new records? So I'm looking for an HTTP verb and a URL. What combination there would we want to use? Okay, post is the verb. It's not .add, so we do want to do post, but if you remember, for getting or read the data, we did get/hubs. So now we know we want to do a post, but what will our URL be? I kind of want you to think about this a little bit, because when it comes to designing an API, the URL, or the URI as it's often called, choose to expose or to publish as part of your documentation and explaining to developers how they can interact with your service. How you name things really makes a big difference. It's really important. Okay, so there is a .add method in our hubs model, so we will be calling that. But of us, the ones that are sending requests into us aren't going to use .add. That's what we're going to use when we call our database. They're going to be making a HTTP using a verb and a method. So Eric says hub/new, and you're very close. The /new we don't need, because by using the post verb, that's our indication that something's going to get created. But it is just hubs, right? So that's correct. So we're going to do post/hubs. Think about it. Essentially, an API request or an HTTP request that comes in with post and /hubs is like telling the Express server we want to add something to hubs, right? So post means add something, and /hubs is where we want to add it, right? So we're going to create a handler for the post verb on the /hubs URL. Okay, does that make sense? And then all of the rest of these, we've got to put our request and response objects in so we can work with those. So what's a little different about a post request from a GET request? When we're asking the server to create something versus telling the server to tell us what it has, what else do we need to provide? So telling it to create something, we've got to give it something a little different than just telling it to return data. Payload, is it good? Okay, we are going to call the add, but it's not on the response object. It is db.add. Is the method that we're going to call, but that's right, Joseph got it. We've got to give it a data object. We have to tell it what to put in the database. And it has to come, Arthur's got it as well. We have to give it something. And that something is going to come from whoever's calling our API. So when they send the request, they need to include some data, and then we're going to use that data to pass it on to the database model, telling it what to create in the database. Okay. So one thing I like to do is consider what is it going to be like for the person using this API when they make the request. So we know that they're going to do a post, they're going to send that post request to hubs, and maybe what we would ask them to pass in is a JSON object that includes a name parameter. okay, whatever they wanted to call it, okay? So we want users of our API to send a post request when they want to create a new record. We want them to send a post request to /hubs. We're going to tell them in our documentation for our API, when you want to create something, you need to give us the name. We'll take care of the rest, okay? In our case, that's what we're choosing to do here. So we know that because we're going to have excellent documentation and they'll know exactly how to use it, that's what's going to come in. Here where we're handling requests, need to be able to access that data, okay? So it turns out that with a post HTTP request, the data is put into the request body, okay? It's what's known as the body. So what we want to do is extract that data from the request itself. So up until now, we've only used the response of our handlers. In this handler, we actually need to access the request object because that's where this data being sent in by the user of our API is going to be, is in the body. So in this case, we know that what they're going to be sending in is information about a new hub. So we'll call our method or hub info. We can call it whatever we want, but that's what I'm going to call it. And we're going to get that information from the body property of the request object. Okay. And then similar to when we did get/hubs, we called our DB object, and it's instead of find, as is many people called it out, we're going to call the add method on our database object. Okay, and that add method will take JSON object that contains our data. Okay, and we know that because we can go and look at the code, or maybe it's documented that we know that it takes a JSON object that has that data in it. Okay, and again, our database object returns promises, so we can put a then clause. And what it will return to us is the object that it added. So if it was successful, what it hands back to us is the very thing we gave to it, but with information. Not only I add it to the database, but I gave it an ID. We're going to get the ID back, and it'll also give us the date in time when it was created back. Okay, so that hub back to us, and then we can do things with it that we want to do. And in this case, what we really want to do is pass it back to the original caller. We want to let them know that the request was successful, and then give them the object that was created so that they can do what they need to do with it, right? So in our case, we want to indicate that it was successful, but one of the things is, as well, I mentioned before that when you're designing an API, and we'll get into this a little later in the course, the way that you name the URLs is really important. If you do a really bad job of that, it becomes confusing and people, it's not intuitive and they find it to use your API. You really want to put some thought into how those are named. But in addition to that, you need to be cautious about what result codes you use. So we've talked about 200, we've talked about 500. There is, and I'll post this later. I should have had it where I could post it now. Maybe one of you will have it. But there is a URL website that shows all the different possible response codes that are appropriate for REST APIs. In this case, when you want to send a result back that says it's successful, but it's for something that was added, it's a bit different than just the 200. You want to use the result code of 201. Okay, and that's a standard response for a post to an API. Okay, thank you, Robert, for posting that. And then we also want to, again, JSONify our object. And the object we're going to send is a property that says that we were successful. This is a little bit redundant because that information is also in the result code, but we want to be verbose here to give them a chance to process it maybe as they're processing the JSON object instead of having to go hunt down the result code. And then we're going to send back the actual object, the hub object. And then, of course, as with any promise, we want to have our catch clause. And our response status is going to be 500 again. And we want to send success false and the error itself. Okay. Hopefully this is, you're recognizing the patterns here and this is making sense. Okay, so again, we're going to pull the body out and we're going to call our database object to add it. And then we're going to successful, we'll take back not just the data we gave it, but all the additional data. And then we'll call return to success with the object. And on an error, we'll send success is false with the error message. Now, up until now, we've been using the browser to test our API. In the case of a post, we really have the ability to specify the body of the request. When you send a post request, you need to add this data to the body, and you can't do that with the browser is an HTTP client that does not allow that. But fortunately, we have an HTTP client that does allow that, and it's post. Okay, so all of the tests that we've done so far, we could have done with Postman. But we could also do them with the browser. So we just went with what we're familiar with. In this case, we don't really have an option. We've got to send this request in using Postman. With Postman, it's pretty simple. You can create additional requests across the top. Each one is a different tab. And here, we specify the HTTP verb. And in our case, we want to send a GET request. And then we send the URL. In our case, it's localhost 4000/hubs. We're going to send a post to that URL. We'll match our handler that we just created, okay? In addition to that, here's where we can specify the body. And without going too deep into exactly what all this means, because we're running a little low on time, plus I think you can get this information online if you want to dig into it, and I'm happy to help out in another context if we can. You want to select raw here, which will allow us to basically create data that's in any format that we want. But when you choose raw, you also specify what type we want to put in the content type heading or the application heading. Okay, and what we're going to send in here is a JSON object. And sending it in as a string, all of our parameters need to be in quotes. Okay. So it's a simple JSON where all we're going to do is send in the name. What we should get back is the object was created with the ID. James is asking if this is in Chrome. It's not in Chrome. It's in Postman. So again, Postman, we wanted to have that installed before. You'll need to have that installed, and then it's just a standalone HTTP client that allows us to send HTTP requests to any location and then control anything about it that we wanted. In this case, we're sending a post, and we're able to specify what we want to send in the body. From those that are using our APIs, whatever application they're going to call our API from, whatever language they're writing that application in, they'll have their own method for constructing an HTTP request and sending it. It could be from Axios. It could be just raw TCP or HTTP request from Sharp application. You know, we could go on and on. Almost every language, this is another reason for the proliferation of RESTful APIs. Almost every language has the ability to send and receive and manage HTTP. So Chaz is asking if we need to specify headers, and in this case we don't. There is going to be a header to indicate what type of data we're sending, but that's going to be automatically added by Postman because we were choosing JSON here. We don't have to go in and do anything specific with other headers. We'll learn more about instances where we do need to do that when we're talking about vacation. We're not doing that yet. That'll come later in the course. Okay. So in this case, I can send the request. We get an error. Okay, it's not what we expected. Now it's also not just some random error. It's a structured error. In fact, error, right? So you note the success false, and then the error object, which includes an error number and a code that was returned to us by our database layer, okay? So what we want to do is try to troubleshoot why we would have gotten this error. Where might we start? Give me an idea of what we can do to try to figure out what might have happened here. Okay, look at the existing data to see how it's structured. Object model. These are places we could look. The Google error code. You'll notice if we back into Postman, you'll notice that the error that Postman got is this 500, if you see where my mouse is. And the reason why it got a 500 there was that's what we told Express to send, right? So here in this post handler, we told Express, if there's an error, send a 500 code with the error text, okay? Okay, so we can look at the schema, not following the API's data structure. Pretty close. Let me jump ahead a little bit and kind of give you a peek into what you might do here. Again, I'm thinking about this from the perspective of my application. Something that sent into the database wasn't right. One of the very first things I'm going to want to look at is what got sent in there. What did it not allow? What got sent in? So things that we do is take a peek at it before we actually send it, right? So right here, after we retrieve the body from the request, let's just put a console.log in and take a peek at it and see what it is it's actually, okay? Because there's something it didn't like about what we sent in there. Okay, and all of these suggestions that you're making are good. They're a good place to begin looking. This is something I was thinking about. You know, what is it about the db.add that it didn't like about what we sent in? Well, I'm not even sure if what I need to get sent in got sent in. So I'm going to put that console log in, and then I'm going to go in and retry. I still get the error, but if I come back here, I can look and see what got logged. And you can see I get an undefined. That's what I expected, right? I didn't expect that. So a little bit of a trick question. The reason why this is happening is because in Express, when a payload like a JSON object comes in like that, it remains a JSON object. It's not specified, right? So it's not in a state that can be passed around. One of the things that we will learn about later in the course with Express is something called middleware. Okay, so I'm going to go to the top of right below where we create the Express server, and I'm going to call a method on Express called use. And what use does is it allows us to do essentially what these HTTP handlers will do, only we apply it to every request. So if there's somebody had asked earlier if there's something that we would want to do on every single HTTP verb and URI, this is where we would do that. So what we're going to do is we're going to call the JSON method to stringify everything about what essentially that method will do is it will take the body, stringify it, and then resave it back to the request object as a string. Okay, and so what use method will do is it takes a function. We could create our own, but in this case, we're just passing one in, and it will execute that function on every single request that comes in, regardless of what the verb is and regardless of what the URL is. Okay, so let me save that. And then if I go back into my Postman client and resubmit the request, you'll notice we get a different response now. Success is true, and we got this hub object back, which includes the data I sent in, plus other data was created as part of the creating ID, which I may want to use later to retrieve this object. If I want to make changes to it, I can use that. And then these data objects that'll know how old it is. Okay. So I'll go back to the code and briefly look at this again. Here we're retrieving the body, and the console log after the body was retrieved is not saying undefined anymore. Over here on the right, it's saying name, it's saying what I passed in, what came with the request. And it's because of this server.use that we did at the top that gets executed before we ever get to this post handler. Okay. And again, we'll talk more about server.use and how that comes into play when we get to the middleware and okay. So we've talked about post and about how to send data in. We've talked a little bit about expressware and making sure that data is in the right format. There are two additional methods that we want to be able to, but we are running behind. It's currently 9:30, and this is I apologize, guys. This is my first class with Linda, and I'm going to ask Chaya to kind of weigh in and help me know what to do here. If I'm supposed to just end on time, or if I should continue going to the end. We've got stuff to do. I'm happy to do whatever is appropriate here, but I'm not sure what is normal for this circumstance.
Hi, Sean. You can continue the class for as long as you can. The students will have time tomorrow to work on the project, but if you still have stuff to go over, it's better if you finish the lecture.
Perfect. These next two sections should take maybe 15 to 20 minutes total, and then we might be able to go through them a little quicker than that because these concepts are getting pretty familiar with everybody. Okay, to be recorded. Awesome. Thank you for the compliment. It's encouraging, and I'm enjoying it too. You guys have been great. All right. So we now have an API that allows us to read and create. So we get a list of all of our hubs, and we can also create new ones. Okay. We're going to dive into the next one, which is 8, and then I'll give a pause for people to catch up, for those of you that might be a little bit behind, and ask questions. We'll do a poll to see where everyone's at. We'll jump into delete because a little bit of a difference with this that I think you'll find interesting. So the next thing we want to do again is create an API that allows us to delete. That's not what I wanted. Okay, we'll come down here. All right, so what HTTP verb do we want to use for telling our service to remove something from the database? Okay, delete is verb. Okay, and what's the URL that we should execute a delete against? Hubs. Okay, that's right. So it's going to be /hubs to be more specific. Okay, so we'll do a server.delete hubs, and then we'll create our method with the request and response objects. Okay, and again, in this instance, when we receive a delete request, we've got to receive, okay, Dave is beating me there. We've got to receive something that tells the server what to delete, right? We can't just say delete. And that, if we did that, we're going to get something very similar to what our Express server was doing. It'll basically say, what am I supposed to do with this? What should I delete? We don't want to delete everything. We want to delete something specific. So we want to be able to pass in an item. Now, when we post, we were able to put information in the body, but here we're working with the delete verb, HTTP, and we don't want to put it in the body. There's a different method that we'll use. And this is actually part of the design of a good REST API is what should the URL like when people are going to call it. I'm probably a little bit more of a stickler than a lot of people would be around this because because I'm a developer and I hate poorly designed APIs. I think people should put some time and some thought into what it should look like, and it needs to be consistent. One of the things that we can do, look at URLs to specify information, is on the URL itself. If we say, look in the hubs collection, we could naturally put something after that, right? That's exactly right, Eric. I use that word craftsmanship in my job all the time. That's exactly what it is. It's what you need. So we could do /hubs as a collection, and then /, and then here's where we could put maybe an ID. Okay, some number, we'd say hub/1 would represent the object in our hubs collection that has the ID of 1, or 14, or 1,367. Okay, whatever we want there. And so that's a consistent way to specify which record or object you want this, this method to execute against. Okay, so in our case, it's going to be a delete /hubs/some ID. Okay, I typically in documentation will represent this in brackets just to show that it's really a template. I want to use the letters ID, but some ID is going to go there. Okay, so that we need to do, if we're going to expect developers that are using our API to pass the ID as part of the URI, we need some way to get it out. Okay, now what I'm going to use here is a JavaScript function called deconstruction. Maybe you're familiar with it, but it's just a convenient way for us to pull information out of an object while at the same time assigning it to a variable. Okay, but what you'll notice here is that signature delete, I have my URL doesn't match what I want it to look like. This is what the developer should send in, but here we want it to look like something different. So this is where there's some syntax with Express that comes into play. If I put a colon in front of that ID, then that signifies to Express that this is a templatized location, that there's going to be some data in there, and it should take that data and assign it to a parameter variable in the request object that has this name. So whatever comes after hubs will be an ID, and it should be saved to a variable called ID on the request. Okay, so here I could say I want to get the ID object of a sub-object on request called params. Okay, so there's an object on the request object called params that include all of our parameters that might exist in our URL. In this case, there's only one, and it's called ID. So the ID object on the params object is assigned to a variable called ID using this deconstruction syntax. So now we have a variable called ID that will contain the ID that was specified in the URL. I want to call a method in our database layer called remove. And the syntax for remove is just to pass in the ID. And again, that's going to return a promise. So we can do a then clause. And what will be returned to us, and what we will want to return to the using I, is the object that was deleted, including its ID and all the other information about it, its name and everything. Okay. So do something with that object. What we know about, we can learn about our data is that if it returns nothing, or if it returns something, okay, then we know that it was successful. And what we want to do is set our status to 204. And again, this is referring back to different HTTP response codes that are standard, and there are some links to what those should be by convention up above. So you can go and take a look at those as you look into designing your API. And again, we'll dig a little deeper into that as we get further into the course. But just trust me, we want to make it be 204 in the case of a successful delete. And then we're going to call another method on the response method. We don't want to send anything back. We just want to tell them it's been successfully deleted. We're going to call the end method. End method is just a method on the response object that basically tells Express, send back a 204 and don't send anything. That's all we need to do. If our database layer returns an empty object and deleted, this means that there wasn't an error. We got an empty object. That means nothing was deleted, and would indicate the IAST was invalid or not correct. Okay, so in that case, we want to send a response. We want to set the status 404, which is in the world of web pages means your web page wasn't found, but in the world of REST APIs, it means something different. Researching to work against doesn't exist. Okay, and then we want to also send a JSON object, and then using our pattern, we're going to say success is false, and we'll include a message in this case. I cannot find the hub you're looking for. These are not the hub you're looking for. Okay. And then that's our then clause. Let me pause here, a couple of questions. Related and thing to format work in Node. I'm not familiar with that format. Sorry, Eric, I'll need a little more context on that. I'm not sure what that is. How come we're using if else statements rather than the catch method that comes with promises? So good question, Jonathan. Let me come back to that in just a quick second. I want to look at Marco's question. So he's asking, spelling out request and response rather than using the abbreviated versions is just a preference, and it is just a preference on my part. I actually don't mind using abbreviated versions. I want to, in this session, I wanted to kind of drive home that that's what they mean, request and response. In the future, you'll see me use REQ and RES. They're just abbreviated versions, but I wanted to kind of continue to do that. So going back to Jonathan's question, how come we're using if else statements? It's because our database layer doesn't necessarily consider it a catastrophic failure. In fact, this kind of gives an opportunity to talk differences in the different classes of HTTP responses that you can get. You also find this TCP and many of the other TCP stack protocols that are text-based follow the same format. And the format is that you've got different classes of errors that have general meaning, and then you could divide those classes down to something specific. So in the case of HTTP, any response in 200-299 range is considered a successful response. But you now have 99 or 100 rather specific codes that you can use to mean specific things about success. 100 means really successful, 201 and 204 are special cases of success that also convey some other information. 300 errors typically mean that it wasn't a failure, but you need to retry your request. And usually there's some information that comes along that tells you to retry that request. In the case of web pages, 300 level errors typically mean what you're looking for is no longer here, and here's the new location. And then the correct thing to do is to re-request with the new information. 400 level errors are considered to be temporary errors. It means that what you've done is given bad information. But that if you give me the right information, then I will be able to fulfill your response. 500 errors are what are considered to be permanent errors. So if you get a 500 back, it means that there's whatever it is you did, there's nothing you can fix it. Bad all the way around. And so in this case, we're differentiating between a failure that says you just gave me a bad ID. If you give me a correct ID, I can work. This is a general catch-all, which we've been using as 500. that says, I have no idea what the problem is, but you're going to, whatever it is you sent, I can't make that work. And so in this case, we're not putting it in the catch where we're assuming that's where an exception is going to be thrown by our data layer that's catastrophic, meaning that there's a permanent failure. It could be that the base is corrupt. It could be that the data server is down, and you can re-request all you want, change the information in your requests all you want, but I'm not going to be able to respond successfully. But in this, we're not doing it in the .catch, we're doing it in the .then, but we're differentiating between something was deleted and something wasn't deleted. If it wasn't deleted, we're that the ID was wrong, and you just need to re-request it with the correct ID. Hopefully that makes sense. So in case, you bet. We're going to follow the same pattern where we set our response status to 100 and the JSON object. Okay, so this should be what we need for our delete method. All right, so what I'm going to do, we could do this from the browser, but since we're familiar now enough with Postman, let's just do Postman. Things that, so what I'm going to do is I have an object here where I know the ID, the object I created, gave me back key of 12. Able to, with my API, I'm going to do a delete on hubs/12. Okay, and that should match my code here. It's going to take 12 and assign it to the ID, and then call the remove method on that, and then we'll see if it worked. Notice we didn't anything back down here, but if you look at our status code, we got a 204. Okay, so that means that it was a successful delete. If I could just do a get on hubs and then take a look at everything that came back. You'll notice I have 1, 3, and 4, and no 12. Right, if I go back to post again and do the same post as I did before, you'll notice I had a new tick back with an ID of, if I do a get, then you'll see I got back 1, 2, 3, 4, and 13. So my new object is in the database. And then I'll delete them to delete /hubs/13. And again, I get my 204. So we can see the delete method working. Okay. Thanks for the comment there. I didn't ask a question, but I apologize for the breakup. If there's some confusion about anything that I have said or have been saying, please let me know. I'll try to clarify. I'm going to go ahead and take a pause here and allow you guys some time to get your code caught up and implement the delete method back into code peek. And again, I'm monitoring the Slack channel, so if you've got any questions, feel free to let me know. Okay, Corey, if you could show me your code. Jamel asks if we could be using Axios instead of Express. Is that what you mean? Your code, I'll take a peek at it and see what that's looking like. It's not sure a 404 on your post, we'd want to look at your code, because the only way a 404 should come back is if you have a response that sends it again. Corey, you can either post or share, whatever you'd like. Although I'm not sure how you share while I'm sharing. Sorry, I'm not a Zoom ninja yet. Still working on that. Yeah, that looks accurate. But you're getting 404 in Postman? Okay. Error 9. I can't see all of what you're sending, but it be a JSON object. You get the open and close curly brackets around it like a JSON object. So you have your name and the value are accurate, but it's got to be in curly brackets. Propose, because like there's a number of people that are having trouble with that. And yeah, the drop down on that needs to be JSON, not text, by the way. That's that was correct, Corey, or Kenichi, sorry. Okay, so let's go over the post again. If you're having trouble with that code, take a peek at it as I kind of go through it here. Again, it's a post handler verb and URL that is hubs. We've got our request and response objects. We're going to get the body of the post from the REST object and send it to a variable that we can use later. And again, if you're having trouble, you can log that to the console, and you should actually see, if you look on my right-hand side over here, you should actually see the exact text that you put in the body in Postman. There, if you're seeing something different, whether it says undefined or something else, then you're going to have a challenge. Okay. The other thing that kind of goes along with is we need to call the express.json method in a server.use call near the top of our file after we create the express server. This is essentially setting up express.json as a method to get executed on every single request that comes, regardless of what the HTTP verb or URL is. And the express.json method is going to um, modify the body such that it can be used by Express. Okay, so when we send in the text that we're sending in, it will take that and turn it into a JSON object that can be used. So down here in the post, we'll see we're going to create an object, we're going to pull the body out of it, and then we're going to use that object to send it into the add method on the database. So without this server.use, it works. And to make sure typing into Postman is accurate. Okay, so let's take a look at Postman. If you look at Postman, you do a post against the hub's URL. You want to make sure that you've selected the body tab so that you can fill in the body, that you have raw, and that you, in this drop down, instead of text, which is the default, you have JSON selected. This is going to automatically set an header that tells Express that this is supposed to be a JSON object. So when we call the JSON method, it'll convert it properly. Okay. And again, what you put here has to be in curly brackets in order for it to work. Okay, Jimmy, what error are you getting in Postman? Yes, and be sure you use double quotes too. Oh, well, what's going to get posted in your console is going to not have the quotes in it. That's what the JSON method in the server.use is going to do is convert that string into a JSON object. Okay. Can you send me a screenshot, Jimmy, of your Postman? Okay. Again, if you'll just look at my screen, you want to make sure that you've got raw and JSON selected, and then you need to have these open and closed curly brackets. The parameter name to be double quotes, and then a colon, and then the value also in double quotes. So both the key name and the value name have to be in double quotes. So Jimmy, Ernesto was getting the same error you're getting, and it's probably for the same reason. Okay. All right. Let's let me just take a quick poll. Let's see. Who's ready to move on so that we can do that, and then we'll find how to help those who need additional help as we can. Jim, you got it working? Good. Okay. All right, let's go ahead and move on then. So far we have a create method, we have a read method, and we have a delete method. And we just have the last one to add will be our update method. And so a typical pattern, it's not necessarily written in stone. You'll find different opinions about this on the internet from different people. But it's one that we followed in APIs that I've in my career, is that the HTTP verb put is what is used for updating existing data. So when you want to create something new, you use post. If you want to update something that exists, you use put. Okay. So what we want to do is create a header that allows us to change an existing object. We're going to use the put method. And this is kind of a combination in terms of the URL and the body, a kind of a combination between post and delete. Okay. Delete uses an ID, and post puts data in the body. In this case, we need an ID so we know what we're updating, and we need stuff in the body so we know what to update it with, right? So here we're going to do /hubs/:ID, just like we did with delete. Just like we did with post, we want to take information that we want to update things with, and we want to get it from the body. Okay, and go ahead and put another console log here just to make sure that what we're passing in is what's being given to our database. Okay. So what we want to do in this case is, again, make a call to our database layer. And the data method that we want, again, we can see this in our hubs-model.js file, is simply update. And it's going to take two. It'll take the ID and then the data that we want to change it with. And like all other promises, we're going to do a then clause. And what's going to be handed back to us when it's successful is an updated object, an updated hub object. And what we want to do with that object, and again, similar to the delete method, if it's a temporary failure, we want to detect it here. The database layer will send us back an empty object if it failed to update it. And so we're going to call that a 400 level error, which basically means probably that the ID was wrong. Okay. So here we're going to check updated to see if it has a value. And if so, then we're going to set our response status to a regular 200. Again, that's a convention for updates that are successful. And then send a JSON object that follows the pattern that we've been using. We'll return the actual new version of the updated object. Okay. But if, however, updated comes back empty, meaning that it didn't work, we're going to assume that it's a bad ID. And in this case, again, we're going to do a 404 at what you've asked me to update this. And we'll send a JSON object. With a message. Okay. And then we want a catch clause to handle any catastrophic failures where we want to send back 500. Okay, so here we'll do 500. And we'll send back a JSON object with the parameter that says success was false. And we'll send back the error object itself. Okay. Hopefully this is making sense. Again, with the, we need an ID, and just like we did with delete, we're going to extract that. Oh, you may notice that I didn't actually extract it. So similar to how we did in delete, we're going to extract it this way using the deconstruction syntax that will get us out of the parameters, which is populated by this template in the URI. And then we'll log our hub, which we're getting from the body. And then we're going to call a database method to update that ID with that information. If it's successful, we'll return a 200 and the new updated object. If it's not successful, we'll return a 404 with a message saying you gave us a bad ID. And if it's a catastrophic failure, 100 with the actual error that came through. Okay, so we'll go ahead and save that. Our server is now restarted. Now, if I go back to Postman, what I want to do just to help myself out is I'm going to do a get, look and see what's in my database. Maybe I want to change the name for number 1. So in this case, I want to do a put. I'm going to pass the same name that I used before when I did a post, but I'll use the same name that I did before. So I'm going to do a put to hub. I need to specify an ID, and I'm going to change number 1 by giving it this new name. And if I hit send, you'll see I got a 200 back. This was true, and my updated ID has an ID of 1, but now it has this new name. And looks to me like there's some database layer that's not working properly. It should have changed the updated property, but it didn't do it. That's something we could look into later when we were talking persistence layer. But if I go back and do a get on hubs, then we'll see ID 1 has my new name, and then the other 3 are still unchanged. Okay, so we'll give you a minute to get caught up on that. Again, it's kind of a combination in terms of syntax between a delete and a post, meaning that we specify an ID in the URL, and we specify new data that we want to update the object with the body, like we did with the post. We're going to extract the ID and extract the body, and then pass those to the database update method. Respond with a 200 if it's successful, 404 if it's not, and 500 if it's a catastrophic failure. So Christina is asking, you get the ID from the rec.params, and the answer is yes. So that's in this part right here. So maybe you posted that before I caught my own error. Yeah, I had to pull that out. So a couple questions. By the way, I posted a yes, no, if you could let me know where you're at in that. Can you change one more? I didn't really catch the problem. I'll go back and do that here in just a second, Jamel. What conditions would lead to the 404 status we've defined? The main one that as far as our current API is right now is using an invalid ID. Okay, so if I were to go into Postman and try to do a put, and then on say, ID number 234. So I'm trying to update some object that has that ID and get a or not found back, because that's an instance where where I ask the database to change something that doesn't exist. Dave asked, catastrophic failure, is that industry lingo? Kind of. Normally in English, when we say catastrophic, we mean, people are dying and limbs are flying and whatnot. That doesn't really happen in most cases with bad software. We won't talk about, Boeing's airplanes and whatnot, because that's kind of sad. But catastrophic failure really means that something bad happened that you cannot recover from. And so in this case, a 500 level error means that it's an error that maybe the server is down or the database is corrupted, or there's something that doesn't matter how many times we send the request in or how many things, there's nothing we can change about the request to make it successful. We're assuming in our API so far that every error that comes back is a catastrophic error. You'll notice that the data doesn't send an exception when we pass out ID. Instead, what it does is it sends back an empty object indicating to us that it didn't do anything. We're assuming that it's because the ID is bad. And there's a lot more we can add to our API to confirm that the structure of the data was accurate. Maybe we can validate IDs ahead of time without making the database layer do it. But in this case, we're relying on it and we're making some assumptions about what it's sending back. Not a super well-defined API, but for the purposes of our class, it's working. But sending in a bad ID is not catastrophic. All we have to do is change it and then it'll work. Any other error that the database sends back to us, we're assuming is whatever it was about our request, there's nothing we can change in that request to make it work. And so we consider that catastrophic. You bet. Robert, you're getting this ID. Request.params. Okay, so part of the problem is, Robert, is that you're using the rec and res shortened versions, where I'm using request, and where you put in where you're getting your ID, you spelled out request.params instead of using rec.params. So you want to pull the params off the rec object, which you've named rec, and I named it request. So I think I'm confusing you because you're using different names than I am. Okay, Jimmy. Yeah, I'll have to see what your code is and what your request looks like. Okay. Okay. Looks like most people are caught up. What I want to do is just let you know about what you can do on your own. Next, we're out of time for class, obviously way over time. I appreciate your patience, and I'll work to honor your time by staying on time next time. I appreciate a chance to get my timing down as I work through this. But the next thing that you could do, what I would recommend you do, is create an endpoint that allows you to, right now we have a get method that returns all of the hubs. Create an endpoint that allows you to specify an ID and return just the one hub. You'll notice that in the hubs-model, there's a method called find by ID, where you just pass in the ID and it returns the one hub. So that'll be the key for how to get it out of the database. But what you'll want to do is design your API so that you can retrieve or receive an ID on the URL, just like we do for the put. And then what you return is a 200 with the hub if it's successful, and a 404 if a bad ID was passed in, and of course the 500 if it's a catastrophic failure. Okay. Okay, and you bet, Marco. It's something I take serious. I'm hoping to help you guys be successful, and it is something I'm passionate about. So I'm loving it. If you guys are okay with that, we'll go ahead and end the class. Jimmy, I'm happy to help out if there's additional help that you'd like with that. And I look forward to meet with you guys on Thursday to continue on with the module. You guys have a great night. Thank you.